Okay, let's unpack this. You've dropped a stack of sources on us, all pointing to one thing. The world of software development is really being fundamentally reshaped.
Yeah, and the engine behind it, artificial intelligence.
Absolutely.
That's right. We've sifted through everything you said. Research papers, industry reports, articles on specific tools, future projections. It's pretty clear this isn't just hype.
No, it feels like a real transformation already happening.
It is.
So today, our mission is to, well, deep dive into this material. We want to pull out the most important nuggets of knowledge for you.
Hmm. Like what's happening right now with AI and coding.
Exactly. And what are the key tools? The tech, making it possible? And, where might this all be heading? Thinking about autonomous AI agents.
Right, but also the limitations, which are crucial.
Definitely need to cover those and tackle that million-dollar question. Will AI actually make coders obsolete?
The big one.
Yeah. Think of this as your shortcut, your essential guide to being genuinely well-informed on this, well, fascinating and really fast-moving subject. Let's get started.
Okay.
So looking at everything, the first sort of big takeaway seems to be how AI is embedding itself across the entire software development lifecycle, the SDLC.
That's right. It's not just, one isolated tool for one phase.
Right.
It's introducing automation, intelligence, really from the get-go, even before you write a single line of code.
In requirements and design, how does that work?
Well, generative AI tools are being used to translate, say, high-level concepts into actual specifications. They can process natural language input from stakeholders
Okay.
and even suggest architectural patterns or generate initial UI mockups, diagrams.
But you mentioned Gen AI for architecture is still pretty new.
It is, yeah. The sources definitely flag challenges there. Things like ensuring precision and avoiding those classic AI hallucinations where it just makes stuff up.
Right. Plausible but wrong. And it sounds like the real power comes from connecting all these different AI pieces together.
That's what the sources really emphasize, comprehensive integration across the whole SDLC. That's the key.
So just using AI for coding, or maybe just for testing, that only gives you small wins.
Exactly. Localized gains. But a holistic approach, integrating AI everywhere, that unlocks these synergistic benefits.
Like what? Better quality overall, faster time to market.
Both. Enhanced end-to-end quality, reduced time to market. You see impacts across all the phases.
Okay, break that down a bit.
Sure. So in coding, you get context-aware suggestions, Copilot style, and automating repetitive boilerplate code.
Saves tedious work.
Definitely. Then in testing and QA, AI can identify potential bugs, even vulnerabilities much faster. It generates adaptive test cases.
Adaptive, meaning they change.
Yeah, they evolve with the code. And it helps prioritize which tests are most critical to run first.
Okay, makes sense. What about deployment?
In deployment and DevOps, you get real-time monitoring, intelligent scaling in your CI/CD pipelines. That's continuous integration, continuous delivery.
Automating the build, test, deploy cycle.
Precisely. And even maintenance gets AI help. Refactoring suggestions, post-deployment optimization analysis.
And project management, too.
Yep. Predictive analytics for timelines, identifying risks, resource allocation. It touches everything.
So it's building towards this vision, one source called a sentient SDLC. That sounds kind of sci-fi.
A little, maybe. But the idea is an SDLC where AI provides continuous intelligence, proactively flagging issues, constantly optimizing processes.
So not just tools, but an intelligent system.
That's the goal. The foundations are being laid now with this push for integration across the board.
Okay, now here's where it gets really interesting for me and maybe a bit counterintuitive, the impact on productivity. The numbers you shared are huge, but you said it's complex.
It is fascinating because the headline numbers are, well, dramatic. GitHub reported a 55% improvement in developer productivity using their AI copilots.
55%? That's massive.
Huge. And we saw other stats suggesting generative AI tools can speed up writing new code by up to 47%, documentation by 50%, and refining existing code by, get this, 63%.
Wow. These aren't just small bumps. Those are like step changes in speed.
Exactly. And you have big names confirming this trend. Microsoft CEO Satya Nadella said AI generates something like 20–30% of code in their internal repos.
20 to 30% already.
And Meta's Mark Zuckerberg anticipates that figure could climb to 50%.
50%, okay. But you mentioned a paradox.
Right, here's the complexity. What one source called the productivity paradox. Faster initial coding doesn't automatically equal a net gain overall.
How so?
Well, for example, research on GitHub Copilot also indicated a potential for a 41% increase in bug introduction.
Wait, hang on. You write code much faster, but you might introduce significantly more bugs.
That's the potential trade-off highlighted. It seems like you could just be shifting the effort downstream.
So less time typing, more time debugging or reviewing.
Exactly. AI might cut down the initial coding time, but it could actually increase the time spent on code reviews, especially if you've got these large pull requests filled with AI-generated code that needs careful vetting.
Makes sense. Any other data on that?
Yeah, one survey really drove this home. 59% of developers reported that AI tools created deployment errors at least half the time.
Half the time. That's
It
worrying.
led 67% of them, a big majority, to say they spend more time debugging AI-generated code than they would have spent writing it themselves.
Okay, that completely changes how we should think about measuring developer output then.
Absolutely.
Lines of code per hour. That metric seems totally irrelevant now, right?
Pretty much useless in this context.
Hmm.
The sources strongly argue we need entirely new metrics. The focus has to shift
To what?
to the quality, the maintainability, the overall value of the final software product. And, crucially, how effectively the humans and the AI are actually collaborating.
Right. It's not just the tool, it's how you use it.
Precisely. And this highlights why this skill of AI curation is becoming so vital.
AI curation, what's that exactly?
It's your ability to effectively prompt the AI, guide it, critically evaluate its output, know how to debug code maybe you didn't write from scratch, and integrate it reliably and safely into the larger system.
So it's a whole new skill set.
It really is. And the huge variance in productivity results people are reporting likely reflects how mature different organizations are in adopting AI. Those who adapt their workflows, upskill their teams, they see more of the benefits.
Okay, that makes sense. So let's look under the hood. What are the core technologies actually powering all this change?
Well, large language models, LLMs, are definitely front and center. They're the tech behind generating code snippets, understanding our natural language instructions, and turning them into code.
Like ChatGPT, Copilot.
Exactly. Those are powered by models like OpenAI's Codex and GPT-4. LLMs are basically becoming this crucial interface layer.
The way we talk to the AI.
Right, allowing developers to interact with these complex AI systems using just, plain English.
So LLMs handle the language and generation. What else?
Machine learning algorithms, ML, are another cornerstone. They're used for more, let's say, analytical tasks,
Like.
assessing software quality, predicting where bugs are likely to crop up, automating parts of the testing process, providing those predictive analytics for project management we talked about.
Are these new algorithms?
Some are, but often they're established algorithms applied in new ways. The sources mention things like naive Bayes and random forests. These are types of classifiers, good at finding patterns being used to identify parts of code that are good candidates for refactoring.
Okay. And you mentioned natural language processing, NLP. How does that fit in?
NLP is what enables the machines to understand human language in the first place.
So it feeds into the LLMs.
It's fundamental to how LLMs work, yes.
Yeah.
In software development specifically, NLP lets AI tools convert a feature description into code requirements, analyze documentation, understand the context from code comments.
Which helps tools like Copilot give relevant suggestions.
Exactly. Based on comments and docs, not just the code itself. But what's really fascinating, according to the sources, is how these technologies have a kind of symbiotic evolution.
Meaning they help each other improve.
Precisely. Progress in one area, like LLMs getting better at generating code, actually spurs innovation in others. For instance, better code generation might lead to creating synthetic data sets.
Fake code.
Yeah, realistic but generated code, used to train more robust ML models for things like quality assessment or bug prediction. And those improved ML models then provide feedback that helps refine the LLMs. It's a cycle.
A virtuous cycle, hopefully.
Hopefully.
And this evolution has clearly fueled just an explosion of AI-powered tools specifically for developers. It really feels like the IDE, the integrated development environment, is changing.
Oh, absolutely. It's becoming less just a code editor and more of an AI hub.
Yeah. The tools are getting deeply embedded right into the workflow.
Totally. The sources highlighted several key players. GitHub Copilot is probably the most recognized one.
The AI pair programmer.
That's the one. Integrated into popular IDEs like VS Code, trained on, vast amounts of GitHub code, offers real-time suggestions as you type, has a chat assistant too.
Strengths. Weaknesses.
Strengths are definitely speed, supports tons of languages, and it adapts somewhat to your coding style. Limitations. Well, it can generate incorrect code or even insecure code.
That's a big one.
Huge. And there's the risk of developers becoming over-reliant, maybe not thinking as critically. It's subscription-based, around $10 to $19 a month, depending on the plan.
Okay. What about Amazon's offering? You mentioned Amazon Q Developer.
Right. Coming from AWS, it's really designed with large projects and enterprise security needs in mind. Integrates with IDEs, but also offers specialized agents for specific tasks.
Agents, like little helper bots.
Sort of. There's like a dev agent for implementation tasks, doc for documentation and diagrams, review for code review assistance, and a command line agent too. Big synergy with the whole AWS ecosystem, as you'd expect.
Nicing.
It's usage-based, which can be good or bad depending on how much you use it.
Got it. And Google, they have Gemini Code Assist.
Yes, that leverages their powerful Gemini LLM. It does the expected things, code completion, chat taka. But a key differentiator the sources mentioned is that it provides citations for the code it generates.
Citations, like where the code came from.
Exactly, or at least inspiration or relevant documentation. Makes it easier for developers to verify the output, check licenses, understand the context.
That sounds really useful, actually.
It could be. It's integrated into Google Cloud Tools, offers IDE plugins, and they have a pretty aggressive free tier for individual developers.
Interesting. Now, Tabyan was mentioned as focusing on something a bit different. Privacy.
Yeah, Tab 9 has carved out a niche with its strong focus on privacy and personalization. That makes it popular in enterprise settings where maybe you don't want your proprietary code going to a third-party cloud model.
So you can run it locally.
It allows for on-premise deployment, yes. And critically, it can be trained specifically on a company's own internal code base.
So the suggestions are much more relevant to your specific projects and style.
Exactly. Much more contextual. It also supports switching between different underlying LLMs and works with, I think, over 30 languages.
Okay. And then there's the big general one, ChatGPT. How does that fit in for coders?
Well, it's obviously a super powerful general-purpose assistant.
Yeah.
Great for explaining concepts, getting template code, helping debug specific snippets.
But
But the sources noted it can struggle with maintaining context in very large, complex applications. It wasn't built specifically for coding workflows, and it isn't natively integrated into your IDE like Copilot or the others are.
so more for ad hoc help than continuous pair programming.
That seems to be the consensus.
Right.
What's clear looking across these tools is the market is definitely not one size fits all. It's specializing.
Yeah, you see that enterprise focus, the privacy angle, the deep ecosystem integration.
Right. It's moving beyond just generic code completion.
And AI isn't just about writing the code faster, right? The sources talked a lot about testing and QA too.
Oh, hugely important area. Tools for automated bug detection are getting smarter. We're seeing intelligent test case generation.
Not just generating thousands of tests, but smarter ones.
Exactly. Tools like test.ai were mentioned, which can prioritize tests based on risk or recent code changes. And there was even talk, maybe a bit further out, about self-healing software.
Whoa, where AI could detect and actually fix certain bugs automatically?
That's the potential future vision mentioned in some sources, automatically detecting and maybe patching certain types of runtime issues. Still early days, but the idea is out there.
Okay. And what about those traditionally really labor-intensive areas like code reviews and documentation?
AI is making inroads there too. For code reviews, AI can help identify potential issues, suggest fixes. LLMs can even generate review comments that sound quite human-like.
Though you still need a human to catch the nuances.
Oh, absolutely. Human oversight is still critical for understanding the intent, the bigger picture, the really subtle stuff. But AI can handle a lot of the first pass.
And documentation. Nobody likes writing docs.
Tell me about it. AI can help generate documentation from code, keep it updated as the code changes. One study saw a 7.5% improvement in documentation quality and currency with AI assistance.
Yeah, that's actually significant.
It is. And in maintenance, too, identifying areas needing refactoring, optimizing systems after deployment based on real-world usage data. Some interesting concepts are emerging here.
Like,
Things like knowledge continuity, using AI to build this persistent knowledge base from code, comments, docs, reviews, so insights aren't lost.
Yeah.
And proactive obsolescence management.
predicting when code is going to become outdated or problematic.
Exactly. Using AI to analyze code complexity, dependencies, change history to predict future code decay, and flag it before it becomes a major issue.
That's thinking ahead. This all leads, though, to a really fundamental question that seemed to run through all the material you sent. Are these tools just really powerful assistants, augmenting what humans do? Or are we starting to see something closer to actual autonomous AI coders, augmentation or autonomy?
That's the core tension right now. The tools most developers use, Daily, Copilot, Tab 9, etc., are primarily about augmenting humans.
The pair programmer model.
Right. They automate repetitive stuff, reduce what the source is called cognitive offloading, freeing up developers for higher-level thinking, more complex problem-solving.
Makes sense.
An Anthropic study you shared was interesting. It found 79% of user conversations with their code model were basically about automation. But
But
the sources are careful to note this still involves a constant feedback loop. There's significant human supervision, guidance, correction. The lines are definitely starting to blur, though, as the tools become more capable, more agentic.
so what's that next frontier then? The truly autonomous part.
That's the emergence of what the sources are calling AI software engineers.
Okay, what does that mean?
These are conceived as more advanced autonomous agents, designed to understand higher-level requirements, maybe just expressed in natural language, and then attempt to execute complex development tasks end-to-end much more independently.
Like the Devon tool that got a lot of press.
Devon, from Cognition Labs, announced in 2024, is a prime example highlighted. The idea is it can take a complex task description, like an issue on GitHub,
And just solve it.
attempt to solve it, yeah, by orchestrating a whole suite of standard developer tools, using a command line shell, a code editor, a web browser, essentially mimicking the workflow a human developer might use.
Okay. Were there other examples?
Autocode Rover was another one mentioned, which was actually acquired by SonarSource. It reportedly showed higher effectiveness than Devon in some specific evaluations.
How does it work differently?
Its focus seems to be more on understanding software intent, using deeper program analysis techniques like autonomous code search within a code base, sophisticated fault localization to pinpoint bugs and then fixing them, and importantly, it can apparently explain the rationale behind its fixes.
That explanation part seems key for trust.
Absolutely. So the power of these agents isn't just generating code, it's their ability to orchestrate and use the existing ecosystem of developer tools, much like a human would.
That feels like a significant shift. Automating entire tasks or features, potentially.
It does signal that potential. However, the sources were really clear on this. Widespread adoption of these highly autonomous agents faces a major hurdle.
Let me guess. Trust.
Bingo, the trust capability gap.
The gap between what the AI can technically do or claims it can do and whether organizations actually trust it to do that reliably, correctly, safely, especially with less direct human oversight.
Precisely. You need an incredibly high level of confidence before you let an AI agent loose on your critical systems. Bridging that gap is going to require developing entirely new methods for verification, validation, testing, and especially explainability for these complex AI systems.
We need to adapt our whole QA mindset.
We do. Traditional methods might not be sufficient.
So even with these impressive advancements, these emerging autonomous agents, it sounds like current AI, both the assistants and the early agents, still has some pretty significant limitations.
Oh, absolutely. Let's be clear about that. The sources point out numerous issues. AI can still generate code that is just plain incorrect.
Factually wrong.
Yep. Or insecure, introducing vulnerabilities. Or maybe it works, but it's incredibly inefficient. Or it just doesn't quite meet the subtle, nuanced requirements of the user story.
Right, the spirit of the request, not just the letter.
Exactly. LLMs in particular can struggle with complex logical modeling. They can produce code with syntactic errors, semantic issues, internal inconsistencies, or code that seems fine for a simple test case but completely falls apart at scale.
And we talked about hallucinations earlier.
Still a major issue. Generating plausible-sounding but fundamentally wrong information or code. They can also lack precision sometimes and suffer from a lack of interpretability.
Meaning it's hard to figure out why it generated that specific output.
Exactly. It's a black box problem, which makes debugging and trusting the output very difficult.
These limitations, then, they really highlight where human skills remain, well, indispensable.
Without a doubt. AI, as it exists today, lacks genuine intuition. It struggles with deep, creative problem-solving when faced with truly novel or ambiguous situations.
Things it hasn't seen in its training data.
Right. Its creativity is largely sophisticated pattern recognition and recombination, not true original thought or insight. It can't easily grasp complex, nuanced business logic. It can't make complex ethical judgments.
Or handle team dynamics.
Definitely not. It lacks the sophisticated interpersonal skills needed for effective teamwork, negotiation, managing stakeholder expectations. Tasks that require abstract conceptual brainstorming, understanding the unstated needs of a client, pivoting strategy based on subtle feedback, designing large, complex, novel system architectures, these are still firmly in the human domain.
And humans have that capacity for continuous learning and adaptation in ways AI currently doesn't.
Exactly. Humans learn constantly from experience, adapt to rapidly changing contexts. Current AI typically needs explicit retraining on new datasets. AI excels at well-defined problems with clear rules and goals.
But humans are needed for the messy ones.
Humans are essential for navigating what are sometimes called wicked problems, those with incomplete, contradictory, or constantly shifting requirements, often with deep social or ethical complexities intertwined with the technical ones.
So the boundary between human work and AI work, the human-AI frontier, it'll keep shifting.
It'll continuously shift as AI capabilities improve. But the key takeaway from the sources isn't human obsolescence. It's a co-evolution of roles.
Humans move up the stack.
In a sense, yes. Focusing more on higher-level strategic thinking, creativity, ethical oversight, judgment, and importantly, learning how to effectively manage, guide, and evaluate the AI systems themselves.
Which brings us, inevitably, to the million-dollar question, the one everyone really wants answered.
Okay, let's tackle it.
Will AI make coders obsolete?
This is the big one, right?
Right.
And the sources presented a spectrum of opinions, it's fair to say.
Any predicting doom for developers?
You do see some tech leaders making bold predictions. Figures like AI eventually handling maybe 95% of coding tasks were floated, which, if true, could potentially make traditional junior developer roles, those focused primarily on implementation, much less necessary.
And those stats we heard earlier from Microsoft and Meta.
Right, 20–30%, potentially 50% of code being written by AI. That certainly fuels the concern that the volume of human coding might decrease significantly.
Okay, so that's one side. But what was the more common view?
The predominant view, the consensus among the experts and analysts cited, is firmly augmentation, not elimination.
AI is a tool, a powerful one, but still a tool wielded by humans.
Exactly. The common thinking is that AI will automate the more routine, repetitive coding tasks, freeing up human developers to focus on higher-value work, complex problem-solving, system design, architecture, creativity, user experience, ethical considerations.
And there was that surprising statistic about job growth.
Yes, that's striking. Despite all this talk of AI taking over coding, projections from the U.S. Bureau of Labor Statistics actually anticipate continued strong demand for software developers.
How strong?
They projected 17.9% growth between 2023 and 2033. That's way above the average growth rate projected for all occupations.
Wow. Okay, that seems completely counterintuitive. If AI writes more code, why do we need more human developers?
It points to a fundamental redefinition, really, of what coding means and what the job of a developer entails.
Explain that.
Well, if you define coding very narrowly as just the physical act of typing programming syntax, then yes, that specific activity will likely diminish significantly.
AI will do more of the typing.
Right. But if you define coding more broadly as the process of problem-solving, designing systems, structuring logic, thinking computationally, and ultimately instructing a machine to achieve a desired software outcome.
Then it's not disappearing, it's changing form.
Exactly. The way we instruct the machine might change. Maybe less manual syntax, more high-level specifications, maybe more natural language interaction, sometimes called vibe coding. But the core intellectual work of defining the problem and designing the solution remains. The job titled developer will likely persist, but the day-to-day activities will shift dramatically.
Okay, but this does bring up that potential issue you flagged earlier.
The junior developer paradox.
Right. The pipeline problem.
Exactly. If AI starts automating many of the entry-level, more routine coding tasks that junior developers traditionally cut their teeth on.
How do they gain the foundational experience needed to become senior developers?
That's the paradox.
Yeah.
It might become harder to get that initial foothold and build up the skills and experience. The data mentioned did suggest a concerning trend, a drop in junior job postings coinciding with a rise in demand for experienced engineers.
Creating a potential experience gap in the future.
It's a real challenge the industry needs to think about. We need to figure out new ways to onboard and develop talent in this new AI-augmented landscape.
Okay. So, if developers are spending less time on routine implementation, what does their role transform into? What are the new core activities highlighted?
It shifts towards higher-level, more strategic work. The sources painted a picture of future developers focusing more on things like system architecture and design.
Big picture thinking.
Right. How all the pieces fit together, making strategic technical decisions. Also, strategic problem solving, really digging deep into complex business needs and figuring out how software can provide innovative solutions.
And managing the AI itself.
Absolutely critical. AI management and curation becomes a core skill. Knowing how to skillfully prompt, guide, validate, debug, and integrate the outputs from various AI tools. It's not passive acceptance, it's active direction.
What else?
Increased responsibility for security and ethical oversight. As AI writes more code, humans need to be the ultimate arbiters, ensuring it's secure, respects privacy, avoids bias, and aligns with ethical principles.
The human BS detector, essentially.
Kind of. And finally, innovation and creativity. Using AI not just for efficiency, but as a tool to explore totally new ideas, prototype faster, push the boundaries of what's possible with software.
It really sounds less like a traditional coder and more like, I don't know, an AI orchestrator.
That's a great term for it. Directing a symphony of different AI tools and capabilities to achieve a specific complex software outcome. The sources also suggested a rising demand for what they called full-spectrum developers.
Meaning?
Developers who combine strong technical skills with deep domain expertise in a particular industry, finance, healthcare, manufacturing, whatever it might be.
Why is that combination so valuable?
Because they can guide the AI much more effectively to solve the really nuanced, specific, real-world problems within that domain. Generic AI might miss the subtleties that someone with deep industry knowledge understands intuitively.
So, to thrive in this future, developers need this multifaceted skill set. It's not just about knowing Java or Python anymore.
Far from it. It's a blend. You still need technical skills, of course, but they evolve. Proficiency with the AI tools themselves. General AI literacy, understanding capabilities and limitations, prompt engineering becomes a skill.
Knowing how to talk to the AI effectively.
Right. Data analysis skills to evaluate AI outputs, system architecture knowledge. But maybe even more important now are the cognitive skills.
Like critical thinking.
Top of the list. Critically evaluating AI suggestions, not just accepting them. Complex problem solving for those wicked problems AI struggles with. Creativity. Analytical skills. And perhaps the most crucial one, continuous learning and adaptability. The landscape is changing so fast.
And you mentioned soft skills becoming even more important.
Absolutely. Communication is key, explaining complex technical decisions to non-technical stakeholders. Collaboration, not just with other humans, but learning how to collaborate effectively with AI teammates. Empathy for users. And ethical reasoning, plus that domain expertise we just talked about.
It sounds like what you might call a meta-skills renaissance.
That's a perfect way to put it. How you think, how you learn, how you interact and solve problems becomes just as important, if not more so, than mastery of any specific programming language syntax. That syntax skill is becoming less of a differentiator because the AI can handle more of it.
And you made a strong point about ethics becoming core.
Yes. The sources really emphasize this. Ethical proficiency is transitioning from being a specialist concern or an afterthought to becoming a core engineering competency.
Why the shift?
Because developers are increasingly overseeing AI systems that make design choices or generate significant amounts of code. They must take responsibility for ensuring those systems operate ethically, responsibly, fairly, without bias. It's not just for ethicists anymore. It's part of the fundamental job of building software in the AI era.
Okay. Looking ahead then at the broader market, the sources painted a picture of explosive growth for AI and software development. The numbers were pretty staggering.
They really were. The global market for generative AI, specifically within the SDLC, was estimated around $266 million back in 2022. The projection, over $2.8 billion by 2030.
Wow, that's more than tenfold growth.
With a compound annual growth rate, a CAGR, of over 35%. And within that, code generation is the largest and fastest growing segment. This level of investment is just pouring fuel on the fire for R&D and faster tool development.
But this rapid growth, this gold rush, it also brings significant challenges and tensions that need careful navigation, right?
Definitely. One key tension highlighted was this balance between democratization.
AI making it easier for more people to build software.
Potentially, yeah. Lowering the barrier to entry. But that's balanced against the trend towards centralization. Meaning the control of the most powerful foundational AI models resides with just a handful of very large tech companies.
Yeah.
You know the names. Microsoft, OpenAI, Google, AWS, Meta.
So that creates dependence.
It could lead to dependence, yeah. Potential vendor lock-in. And it means a few major players could wield significant influence over the entire future direction of software development tools and practices. That's a concern.
And beyond market structure, there are those major hurdles for responsible adoption we touched on earlier, especially around trust.
Absolutely critical. Trust is paramount, especially as we move towards more autonomous AI agents. This demands rigorous, new approaches to quality assurance, testing, verification, validation specifically for AI systems.
What other major hurdles?
Security and privacy are huge. AI-generated code could inadvertently introduce new kinds of vulnerabilities. And the process itself, feeding potentially sensitive code or data into AI models, raises privacy risks that need careful management.
Bias is a big one, too.
Algorithmic bias and fairness? Yes. If the AI is trained on biased data, which reflects historical biases in society or even in past code bases, it can perpetuate or even amplify discrimination in the software it helps build. That's a massive ethical and societal risk.
Plus the accuracy issues.
Accuracy and hallucinations remain persistent challenges that need robust mitigation strategies.
Yeah.
And overarching all of this are the broader ethical considerations and legal compliance issues.
Like accountability. Who's responsible when AI messes up?
Exactly. Accountability, responsibility, intellectual property rights for AI-generated code, the societal impact of AI-driven automation, ensuring compliance with evolving laws and regulations. And that fundamental lack of explainability and transparency in some of the most complex models makes all of this harder.
The sources talked about this potentially creating socio-technical debt. That sounds serious.
It is. It's a concept suggesting that failing to address these issues isn't just creating technical debt, like messy code. It's accumulating social, ethical, and potentially legal debt at scale.
Which could bite you much harder later on.
Much harder. It could seriously undermine user trust, lead to regulatory action, cause significant brand damage. To address this, the material suggested we're likely to see the emergence of a new specialized field, maybe called AI assurance.
Focused on what?
Focused specifically on auditing, validating, verifying, and continuously monitoring AI systems and their outputs, ensuring they meet standards for safety, reliability, fairness, security, and legal compliance. Kind of like QA and compliance specifically for AI.
Okay. All of this change, all these challenges, it clearly means we need a fundamental rethink of how we educate and train software engineers for this future.
Absolutely fundamental. Adaptability and continuous learning have to become the absolute cornerstones. Gartner had a striking prediction. 80% of engineers will need significant new skills by 2027 just to remain effective in their roles.
80% by 2027. That's almost everyone, very soon.
It underscores the pace of change. Educational curricula, from universities to boot camps to corporate training, must evolve rapidly. They need to incorporate AI literacy, hands-on experience with AI development tools, and crucially, a deep understanding of AI's limitations and the associated ethical implications.
And going back to that junior developer paradox, we need proactive strategies there, right?
We absolutely do. If AI handles more of the simpler introductory tasks, how do new entrants gain that essential foundational experience? We need innovative models.
Like what?
Maybe more sophisticated, simulated, complex projects and training. Perhaps new forms of AI-focused apprenticeships, mentorship programs centered specifically on developing human-AI collaboration skills. We need new pathways.
And we'll see new roles emerge, too.
Definitely. Beyond the evolution of the traditional developer role, there's already growing demand for AI-specific positions. Machine learning engineers, data scientists specializing in ML, generative AI engineers focused on building and fine-tuning these models.
But for the core developer role, the skills focus is definitely shifting.
Yes, away from routine coding proficiency and towards those non-routine skills. Deep analytical problem solving, system architecture, effective communication, critical thinking, creativity, ethical reasoning. Those meta skills and ethical proficiency become absolutely central.
And new career paths are opening up.
Yeah, especially in non-tech industries. Companies in finance, healthcare, retail, etc., need developers who understand their specific domain and know how to apply AI effectively within that context. The sources painted this picture of a potential bifurcation in the field.
Two main paths.
Kind of. One path specializing in actually building the core AI and ML tools and platforms, and another, perhaps much larger path, focusing on AI-augmented software engineering.
Using the tools rather than building them.
Exactly. Using AI tools to design, develop, and deploy applications across all sorts of domains. with a stronger emphasis on architecture, product strategy, domain expertise, and ethical implementation.
Okay,
All right.
so let's try to sum all this up. It feels like the bottom line is AI is undeniably catalyzing a massive paradigm shift in how software gets built.
No question. It's accelerating development, enabling new kinds of innovation, and fundamentally reshaping the work, the skills, and the role of the developer.
But, and this seems like the crucial but, from the sources, the consensus points towards this being about augmenting human capabilities, creating a new kind of human-AI synergy.
Rather than making human coders obsolete entirely. That's the prevailing view.
So how should individuals and companies navigate this seismic shift? The sources offered some clear strategic recommendations for developers themselves.
The message was pretty consistent. Embrace AI not as a threat, but as a powerful collaborator. Actively cultivate those non-routine skills we keep coming back to: complex problem solving, system architecture, creativity, communication, ethical judgment, domain expertise.
And keep learning.
Commit to continuous learning. Specifically, gain AI literacy, learn prompt engineering, and maybe consider specializing either in AI itself or in applying AI within a high-demand industry niche.
Makes sense. And for organizations, what's the advice?
Integrate AI thoughtfully and strategically across the entire SDLC, not just piecemeal. Invest heavily in talent development. Upskilling and reskilling your existing workforce is critical.
Address the pipeline issue.
Yes, proactively nurture the future talent pipeline, figuring out how to onboard and grow junior talent in this new era. Implement robust governance and quality assurance processes specifically tailored for AI-generated code and AI-assisted workflows.
Don't just trust the AI blindly.
Absolutely not. And finally, foster a culture that encourages experimentation, learning, and continuous adaptation to these new tools and methods.
It seems the future of software development really is going to be defined by this dynamic, evolving interplay between human intellect and artificial intelligence.
That sums it up perfectly.
As we wrap up this deep dive then, what's the biggest thing that stands out for you listening to all this analysis? This exploration of the sources really shows us that the developer of the future isn't just defined by the programming languages they know.
No, their value lies increasingly in being an architect, a strategist, and orchestrator of tools.
And critically, an ethicist responsible for the impact of the systems they help create.
Yeah, if we connect this to the bigger picture, it's not just about building software faster, is it? It's about leveraging AI to potentially build better software, more reliable, more intelligent, more accessible, and hopefully built more responsibly for an increasingly complex world.
So here's a provocative thought, based on everything we've discussed, to leave you with. If AI gets truly proficient at writing the code itself, what then becomes the uniquely irreducibly human contribution left in the complex art and science of building the software that shapes our modern world?
That's the question to ponder.
Thanks for joining us for this deep dive.